Hey guys, let's take a look at the question number 23, merge k sorted list. I think we've done the simple one, like merge two sorted list, right? Okay, here, merge k sorted linked list and return it as one sorted list. Analyze and describe its complexity. 1, 4, 5, 1, 2, 3, 2, 6. I think this should be just done with the same, right? With 2. With still remember that in merge two sorted lists, we use 2 pointers. So for k, we use k list. If we use k pointers, and how can we manage them? It doesn't matter because we use k pointers. Yeah, shouldn't be that difficult. I think I can, but I'm not sure about the performance. So anyway, let's create it. So let's just create a const start equals new list node 0 const point piece equals lists map list list. Yes, p list equals list So now we have to consider which one is small and which one is big, and just update them one by one, right? So, while p list length is bigger than 1, well, there is still list is not handled. We will loop through let i smaller than p list dot length I plus plus. So for each p, we'll find the max. Let max be null. So if p list I val is bigger than max p to val, max p equals max p equals p list I. So we find the max find the max append to the result. So const p equals start. So p next equals max p. Max p equals max p next. But we have array. But if we're using array, we cannot remove, right? So we just we don't use to update max next, but just say p list Oh, we need to. Index, okay, we say index. Index equals 0. So p I equals p list max p index. The val index equals I. So p next, it should be p list max p index. P list max p index should be p list max p index. Next. So for each, we compare and we update. This is the max. We update it to here, and p next equals this one. So p next one, and p equals p next. So and update p this p to the next one. Yeah. If p, remove it from the list if null. So if p we could use a set without using this p list, right? Yes, we can use set. But if you the sort list are the same, yeah. Anyway, if p list max p index is equal to null, then p list splice this one and 1. And finally, when everything is done, we return start next. Let's test run it. Assignment to constant value. Constant value? Oh, let. One four five 13426. I got 2614. What the heck? Okay, we got this, so we. Because it's list, right? Yeah. Ah, we should find the min. Sorry. Not maximum, but minimum. Shit. Here. It's accepted. It's free. Sort of list. It's cannot read val of more. But I splice it. P list. Runtime error. More. It said it's empty. Filter. This is, you need to filter if empty list, so the list filter list. Filter it. Submit. Output time. So this way it's actually working, but it's takes too much time. Merge to list. It takes m plus n, right? If we do like this, so let's first say here is m. Let's say m list n n items. So m times n for each round, and for each for m times n, there are rounds. For each round, we will compare. So m n, we will check again, find the minimum. So it's m again, m square n. Yeah. How can we improve it? So improve it. One. We can sort. We can sort the list. Yeah, right? Like 1, 1. If we sort, we got like quick sort. n log n, and then we just so if we sort, we got like 1 3 4 1 4 5 2 6 1 3 4 1 4 5 2 6. So we put this one, put this one. We can improve it by sorting. To avoid searching every time. Ah, wait a minute. So if we sort it, we can now just insert it. So it's gonna be, if once we sort it, so that will be m n m log m, and after that we get the minimum, and now we will just need to insert it. So that case will be only m. So it will be plus m times so it will be times m times n, but m square, still m square. For our solution here, it should be m, and every time we search, compare, it will be m. It doesn't help much. But that would be faster because we don't need to search them for all. We can save saves averagely. I think it will be saving us from. We only need to compare this one and then this one. This is the smallest. Right? That's the top three. Let's say 1 1 3 2 4. Okay, got this one, go, and then let's compare these two. Big, then you. This is smallest, and then you. That's bigger. Then we change. Change. But if it's smaller again, it will be just get it down. Will this save a lot of time? Would this save a lot of time? Anyway, let's have a try. So first, we need to sort. Sort list p list sort. Return a val minus b val. So now, each time we found something, we just move the first to the result. So p next, it should be p list 0. P equals p next, p list 0 should be p next 0.next. Now, adjust the order of the p list. Remove it from passive null, so that should be 0 and then should be 0. Okay. Adjust the order. Now we don't need to use the log m quick sort. We just use the insert. We have to do the insertion. Anyway, we just do it. We just do it without cheating. Adjust the order. We sort. We sort. We don't need. We cannot sort. We shouldn't sort. Yeah. Adjust the order. If for let I equals 0, I smaller than p list length I plus plus. It should be E1. If p list I val is bigger than p list 0 val, then break. But when you break, you should do the insertion. No, it should be. So all this is small, but you will find somewhere you bigger than and a smaller than. You find the first smaller than thing. If it's small here, okay, bigger, smaller, let's insert it. Okay. We use a JavaScript cheating. Splice. If I is bigger than 2, so if then it repeats splice I plus I 0 p list shift. All right. Wrong wrong answer. It is sorted, but it is 0 plus the next, so it is 4. 4 because 4 is there's a problem with finding. You should find while it's big, so yeah. Let k equals I while p list k. This should be smaller than it. While smaller than p list I 0 while k plus 1. So we will find the first k, which is bigger than it. If pk is not null, and this, right? Oh, yeah. Wait, should be k. If k smaller than p list, if k smaller than p list, then p list splice k 0 p list and shift. Else p list push p list and shift. Time limit exceeded. It should time limit exceeded couldn't be happen here on this test case. Let's there's something wrong in my code. Copy this way, sorted, restart. 4. So this 1, 3, 2, 3. plist, why it's so long? Ah, not unshift, it's shift. Shit. Wrong answer. What's the answer? Should be 1, 2, 1, 1. 1, 4, 5, 1, 3, 4, 2, 6. 1, 2, 1, 3, 4, 4, 6, 5. Console log. Console log plist. So it's 2, 6. 2, 6, 4, 5. 1, 3. Next is a string. Next is array. 1, 3, 4. So 1, 4, 5. Okay. 1, 3, no. 4, 5. Sort is foul. What is foul? It is string. 1, 1, 1, 2. It's right. It's not. My bad. Vel. It's actually right because we removed 1, 4, 5, 1, 3, 4, 2, 6, and then we got while k and this one k is equal So 4, 1, 2. K is smaller than it. Yeah, it's right. It should be moved to 2, 4. Mm. 1, 4, 5, 1, 3, 4, 2, 6, and then 2, 4, 1. Huh? 2, 6, 2, 4, 1, 3. Okay, so we got it to, it should be 4, 5. Okay. So it's 1, 1, 2, and then 1 should be through 2. Ah, there's no there's no need to do this order, so it should be K1. Oh my god, my brain's not working. Yeah. So 1, 3, 5. Okay, 2, 6. 1, 3, 5, 2, 6. Okay, so we now move on 3. So it says 3, 2, 4, 3. It should not be 2, 4, 3. Why? 3, 2. Here's one then, and continue. So it's 1, 4, 5, 1, 3, 4, 2, 6. I got this one. So 1, 3, 4, 2, 6, 4, 5. And I got this one. It's 2, 6, 3, 4, 4, 5. Got 4, 5, 3, 4. Why? K. So for here, we compare 3. Okay, 3 here. Here. Small. Ah. Shit. -1. I'm not sure if this approach could pass or not. Hope so. maybe time limit exceeded. Ooh, we passed. So about these solutions time complexity, we can see that first we have to, so there is m list, n averagely there will be n numbers. So actual time complexity should be it should be O. Actually, we do the list sort, so it should be m log m plus this is a while loop, so it should be m, and this will be ends at this time. For every time we move an element, there will be averagely, I think, half of m compared. So it should be m squared, m o m square about extra space complexity is O1. We only created only one. See at the solution, brute force. Traverse all the linked lists and collect the values from nodes into an array. Sort and iterate over this array to get the proper value of the nodes. Create a new sorted list and extend it with new nodes. This is not good. This time, space complexity is O(n). Yeah. And its total number of nodes. So it will be, yeah. Collecting all the values costs O(n). Stable sorting costs n log n. Iterating for creating a linked list costs O(n). Not bad. But O(n) log n, we have got O. So we are not having this mn, m squared. If it is saying this n, that it should be n. It should be time complexities. Yeah, km. One, 2, 3. Okay, compare. Yeah, this is the first brute force, but the time limit exceeded. Almost every selection of nodes in the final cost OK. Yeah, the brute force solution, we compare them. So it will cost k. It means k. Yeah, OK, and n nodes kn. Yeah, sure. But if you say lat, we have currently we will have n compare. For each compare, we averagely have Oh, it doesn't change that much. We can do the binary, right? So n times k, we can use the log k. Oh yeah. Optimize approached by priority queue, almost the same as the one above, but optimize the comparison process by priority queue. What is priority queue? Always get the minimum. Ah, yeah. Priority queue. Head, okay, for list, if put queue predicate queue. Why not empty, get, next, node put. Priority queue. Yeah. Divide and conquer. This approach walks alongside the one above, but it improves a lot. We don't need to traverse most nodes many times repeatedly. Pair up k-lists and merge each pair. After the first pairing, k-lists are merged into two tags with average, then k, and so on. Repeat this procedure until we get the final sorted linked list. Thus, we'll traverse almost n nodes per pairing and merging, and repeat this procedure above log to k times. Oh, this will help. Wow, divide conquer. This is a divide conquer. Merge two lists. We merge two of them, and then we merge two of them. We will have complexity n log k. Where k is number of linked lists. We can merge two on time, and insert number of nodes into list, and then sum of all the process we can get. Wow, this is cool. I learned something about priority queue. Maybe we were doing interviews, we can suppose in some languages in JavaScript, because we don't have those data structure, we can just suppose there are like a heap and the priority queue. I'll memo something. Suppose we can have priority queue heap. Priority queue is heap, right? Heap. Priority queue often implements heap. They are conceptually distinct from heaps. A priority queue is an abstract concept like a list or map. Just as a list can be implemented with a linked list or an array, Operator can be implemented with a heap or a variety of other methods, such as a non-ordered array. In computer science, a priority queue is an abstract data ADP, which is like regular queue stack, but where additional elements has a priority associated with it. In a priority queue, an element with high priority is served before an element with no priority. Ah, yeah. Priority queue always, yeah. Let's see. Cool, but in JavaScript there's no priority queue. Anyway, we'll finish this program, but honestly, it's not that bad, I think. Submission just faster than 55%. Let's look at the possible better solutions. Merge the lists. Merge this AB. Return done. What is this? Yeah, they're taking the approach of merge them, divide and conquer. Merge two list, yeah, cool. The first merge two list, and then we start merge two list start and end, and merge this one start and then start. Until there is only one empty string, one list. Cool. Let's try. I don't remember the merge. What is the number? Problems. I think it should be maybe there are in the list of so many questions. Merge to sorted list, right? This one. We can copy this code here. Yeah, this one is a little cumbersome. Let's copy this better one. This one. Okay. Let's copy it, put it here. Okay, because this is merge two lists, this will return new one, right? Okay, so while list's length is bigger than 1. No, we should not use a while the length, but let's start equals 0. Let end equals lists length minus 1. While start is smaller than end. Start equals 0. When to merge, when two lists are merged, the first one is used, so we will pop. So I can use that. While list's length is bigger than 1. let start equals 0, let end equals list.length. Well, start is smaller than end. Start plus 1 and minus equals 1. We merge two lists. Lists start, lists end, because the lists start equals this one. Oh, that end. So sorry, it should be end should be wow, end is bigger than 1. Well, start end, okay, we will merge them all. And then, because end always minus 1. Minus 1, minus 1. Will this create a new list? Start and the new one, new one, new one. So the end should be start. Because it's the end of start. So end should be start. Start equals 0. And then we finally return lists 0. Run the code. Time limit exceeded. Wow, n this is bigger than 1. Start 0, n, or start n, and let's start merge two lists. And date equals start equals 1. Wow, we just the console log start and start. There's no start. There is start. What? Start is not defined. What do you mean? This is start. End is not defined. What? I shouldn't let this one, the end. This is the right code. Also log word start and this, yeah, shit, should that be bigger than 0? Merge 2, and 1. Well, true. Oh, there's a mistake. I shouldn't say end equals start, because start, end, so actually should bigger than, it should end -1, and then the end here should be n bigger than 1, bigger than 0. Wrong answer. Word 1 to 2. Console merge to 1, 2. Start end, and then there's a meeting problem. The end should not be like this. Start, next one. Yeah, if start equals n, n equals start, else end equals start -1. This is right. Yeah. Will this be faster? That's a log. Huh? It's not that fast, but it is an elegant solution. When two ends meet. Okay, so that's all for this question. Thanks for listening.